GeoSynth, a photorealistic synthetic indoor dataset for scene understanding. Many augmented reality applications, such as the removal of real furniture from a scene, rely on advanced computer vision algorithms and deep learning models. With state-of-the-art methods, critical elements of a scene's lighting and geometry can be estimated to allow for the realistic insertion of virtual objects. To train a deep learning model, we need an annotated dataset that maps given inputs to outputs we would like to predict. Conventionally, datasets are created by gathering a large number of images relevant to a desired task and having human annotators painstakingly label the data. Not only is this expensive, tedious, and time-consuming, it's also an error-prone process. An alternative is to create a computer-generated synthetic dataset to reduce the need for expensive human annotated data. In this paper, we present GeoSynth, a photorealistic dataset aimed for training neural networks in the task of indoor scene understanding. The process of creating any large-scale dataset starts with room acquisition. We want to gather as many scenes as possible that contain high-quality materials and textures, are representative of real-world residential homes, and are Blender compatible. We sourced our assets from IKEA's 3D catalog, public Blender marketplaces, and developed some additional assets in-house. Our goal is to generate hundreds of label-complete variations of a room from a single standalone Blender file. To maximize the number of ground truth packages generated from a room, we introduced the concept of a variant using Blender collections. We consider 4 types of collections: cameras, lighting, materials, and layout. Each of these collections is automatically built using heuristics. Most existing synthetic datasets require large amounts of tedious and expensive manual work. We optimize this process by developing an in-house annotation tool that enables rapid object labeling, lighting modeling, and scene debugging. With this toolkit, we are able to efficiently render over 18,000 exemplars from 36 distinct rooms at a fraction of the cost compared to other similar datasets. Each exemplar contains an RGB render of the scene and 20 ground truth assets categorized in 4 groups: camera intrinsics and extrinsics, geometry attributes like depth maps and surface normals, instance and semantic segmentation labeling, lighting models and assets like environment maps and image intrinsic decomposition components. To show an application of GeoSynth, we trained a semantic segmentation model and fine-tuned it on the NYU V2 dataset. On the top left, we have training from scratch, top right is training from GeoSynth, bottom left is training from ImageNet, and bottom right is training from ImageNet, then GeoSynth. On the bottom left, we have a chart reporting the mean intersection over union performance over the test dataset. Pre-training on GeoSynth significantly improved performance over training from scratch. From ImageNet weights, GeoSynth does not improve the MIOU score on the dataset. Despite this, the segmentation results appear sharper and more coherent. Thank you.